All right, this is a lecture about stoichiometry. This lecture is about stoichiometry, and stoichiometry is simply the mathematical relationship between different substances in a chemical reaction. And stoichiometry all hovers around the coefficients in front of each of the reactant and substances. The first thing that's different that you need to be aware of in doing stoichiometry problems are mole ratios. And the mole ratios are based entirely on the values of these coefficients. And for example, if I asked you, what is the mole ratio of water to oxygen in this reaction? You would simply say 18 to 25. Mole ratios are important because they serve as a conversion factor when we do dimensional analysis or stoichiometric calculations. And what a mole ratio allows us to do is to compare quantities of one substance in a chemical reaction to a different substance in the same chemical reaction. We can do that only with a mole ratio conversion factor. So, for example, if you read the question, it says if we burn 22 moles of C8H18, which is octane, by the way, how many moles of carbon dioxide will be formed? So, as always, in dimensional analysis, we're going to start with the given information from the question, 22 moles of octane. And then the question's asking us about moles of CO2. So we use the mole ratio of CO2 to C8H18 to convert from quantity of the octane to quantity of CO2. So again, just make sure that the units on the diagonal match identically so that they can cancel out. All right, here's one for you to try. So as always, I would recommend that you turn off the video for a minute, see if you can work this out, and then turn it back on and check your answer with me. So the given information is 4 moles of butane, which is C4H10. So I'm going to go ahead and set up my dimensional analysis. I know that my units in the denominator have to be moles of C4H10 because these need to cancel, right? And the substance that the question is asking me about is carbon dioxide. So I know that moles of carbon dioxide go on top. Now this is the mole ratio that I need to move from C4H10 to CO2. To know what numbers to put in front of each of these mole quantities, you look at the balanced reaction. C4H10 has a 2 in front of it, and CO2 has an 8 in front of it. So that would just simply be 4 times 8 divided by 2, and that is 16. 16 moles of CO2. Your final unit is going to be whatever units are in the upper right numerator section of your problem. That will be your units. Alrighty, so this is a mole map that may help you, and so in case it does, in the past we have learned how to convert between moles and mass, moles and grams, okay, and we know that we use the molar mass to do as a conversion factor to do this. Anytime you're going from grams to or from grams, you need molar mass. And then we learned how to convert from moles to particles. So that could be molecules, atoms, whatever. And that we use Avogadro's number as a conversion factor when we're doing that. So what we've learned today that's different is to go from moles of one substance to moles of a completely different substance. Now, it's got to be in the same chemical reaction, but it is a different substance. And in order to go from one substance to another, we need the mole ratio. Once we're in moles of the new substance of interest, We could do the same thing we've done in the past, go back and forth between grams and or atoms. So here's a typical stoichiometry example for you. Potassium chlorate, our given information is 25.5 grams, and the problem tells us that it decomposes into potassium chloride and oxygen. And the problem asks how many moles of oxygen can be formed from 25.5 grams of potassium chlorate, and then how many grams of oxygen can be formed. So remember the generic kind of roadmap, which is grams of the first substance, the given substance, which in this case is potassium chlorate. The first calculation will be converting to moles of that same substance. Step number 2 will be using mole ratio to get moles of the new substance. And finally, the third and last calculation will be converting moles of the new substance to grams of the new substance. So typically 3 calculations. All right, so, and I've got the map rewritten up here in case you want to try to follow along. All right, so again, the first step is to use, to convert mass to moles of the substance. So here we have mass of potassium chlorate. We're dividing by its molar mass, using molar mass as a conversion factor to get moles of potassium chlorate. Once we have moles, we can use mole ratio of the substance that was given, potassium chlorate, times the moles of the substance the problem asks for, which in this case is oxygen. These numbers, 3 and 2, come from the balanced chemical equation, the coefficients. So KClO3 has a 2 in front of it, and molecular oxygen has a 3 in front of it. So now it's just simple math. And this problem also asked for grams, not just moles. Okay, so here are the moles. And of course, to get from moles to grams, you just multiply by molar mass. Be careful for the diatomics. So the molar mass of oxygen atom is 16, okay? Molecular oxygen, which is how most of it exists, it would be 16 times 2 because there are 2 oxygen atoms. So just be aware of that for atomics. All right, so here's one for you to try. It's asking for how much water can be formed from 1 gram of C6H12. So go ahead and set up a stoichiometry problem just like I did. Turn off the video and then come back and check it. So our strategy is going to be to start with the given, 1 gram of glucose. And as always, the first step should be using molar mass as a conversion factor to get to moles of glucose. So 6 there, right? All right, once you have moles, then you're going to use mole ratio in a second step to get 2 moles of the substance they're asking about, which is water in this case. And then finally, read the question.